Today we're starting 4.1, identifying linear functions. The main objective for today is we're going to talk about linear functions and linear equations, and we're going to graph. The two big words right now are linear functions and linear equations. Linear sounds like line. When we graph linear functions or linear equations, they make straight lines. This graph here represents a function because each domain, x value, is paired with exactly one range value, your y values. So 1 goes to 120, 2 goes to 240, 3 goes to 360, 4 goes to 480. Because the graph is a perfect straight line, it is called a linear function. So we're going to tell whether or not the graph is a function.
Teachers, excuse the interruption.
Looking at this graph, I'm looking, do any of the domains x values repeat? Do I ever have two values for one of the x's? No. Is this a perfect straight line?
Yes.
Since each domain is paired with exactly one range, and it forms a line, it is considered a linear function. This graph here, is it a function?
Yes.
To tell if it's a function, I can also do the vertical line test. Or graphing, I look, does my pencil or my line ever hit the graph more than once? At -2, it only hits in one spot. At -1, it only hits in one spot. At 0, it only hits in one spot. 1, and everywhere in between, it only hits in one spot. It is a function. Is this a straight line? No. Since the line or the graph is not a line, it is not a linear function. Do you understand what a linear function is compared to a normal function? How about this one? Is this one a function? Why is it not a function? Go straight up and down. Where does the graph hit my line here? Everywhere, right? On this point, -2 means -1, -2, -3. You have multiple things for -2. -2 goes to multiple answers. Because it's not a function, it can't be a linear function. How about this one? Is that a line? Is this a function? No. The reason it's not, I can take my line. It hits here at 2. It hits here and here. It hits in numerous spots, everywhere except for at 0. That's the only point where it doesn't hit twice. Because it hits twice, it's not a function. We don't always have the graphs. We can look at the tables. So I have a table. The x's are -2, -1, 0, 1, 2. The y values are 7, 4, 1, -2, -5. Looking at these numbers, how does this one change? Adding ones, and these ones are always going down. If I graph those, -2, 7, -1, 4, 0, 1, and so on. When I draw a line through them, it's a straight line. Since it's a straight line, it is a linear function. These should always be the same number. These should be the same number for it to be a linear function. goes -2, -1, 0, 1, 2. Those are all the same number. I have -3, -1, 1, 3. Those are different numbers. When I graph it, it's a U. This is a function, but it's not a linear function because it doesn't make a straight line. It's a function because for every x, there's only one y, but it's not a linear function. I have 0, -3, 4, 0, 8, 3, 12, 6, 16, 9. I want you to tell me whether or not this is a linear function. If I look at my domains, my x values, what's happening between here and here, here and here? All of these are increasing by 4. If I look at my y values or my ranges, each one is going up 3. This is the same. These are the same. This means it's a linear function. I could sit here and graph each one also. 0, -3, 4, 0, 8, 3. I should have counted by a different number. That one's going to be up there, and that one's going to be up there. When you graph them, it's a straight line. How about this one? All of my x values, what's happening? All of these ones are +2. What's happening from here to here? Subtract 12. How about from here to here? Subtract 4. So this one subtract 12. This one subtract 4. This one's this one's add 4, and this one's add 12. It's not the same number, so it's not linear. Another way to determine whether or not something is linear is to actually just look at its equation. A function is linear if it's described by a linear equation. A linear equation is an equation that can be written in standard form. Standard form is ax plus by equals c. A, b, and c are real numbers, and a and b are not both 0. One of them can be 0, but both of them cannot. When a linear equation is written in standard form, x and y, they have to have exponents of 1. If it's an exponent of 1, we don't write an exponent. It's sort of like if we write x, what number's in front? 1, but we don't write 1x, we just write x. X and y cannot be multiplied together. It has to be addition or subtraction in between. X and y cannot appear in denominators. 1 over x is not the same thing as x. They are two separate things. You can't put them in an exponent, or you can't put them in a radical. Radical are those square root symbols. It just has to be plain old x. Here's an example. I have 3x plus 2y equals 10. This is standard form. Here I have y minus 2 equals 3x. It's not standard form, but you can rewrite it into standard form by moving this 2 over and making it positive. Or sorry. Oh, they did it the other way. If all I have to do is move the y over. So I have negative 2 equals 3x minus y. That's standard form. Negative y equals 5x. If I take this y and throw it over, I have 5x plus y equals 0. That is standard form. Yes. I could have moved this the other way, which I was starting to do, but I noticed it was written different. I could have moved this over and had negative 5x minus y equals 0. That's standard form also. Doesn't matter if I move everything to the right or to the left. It's not picky. Here, this is not linear as x times y. That automatically means it's not linear. I have an x cubed. An x to the any power automatically means it's not linear. I have something over y. Y is the denominator, so it cannot be linear. For any 2 points, there's exactly one line that contains them both. This means you only need 2 ordered pairs to graph a line. If I asked you to draw a line, the minimum amount of points you need is 2. The first one gives you location. The second one gives you direction. So looking at this, we want to know, is this linear? Can this be rearranged into standard form? What is out of place? Is it the x, the 2y, or the 4? Which one's out of place? X is okay. The 2y needs to be on the same side with the x. So if I move this from one side to the other, I need to subtract it over. X minus 2y equals 4. It's standard form. It's linear. Now graphing it. To graph, I just need 2 points, but I'll pick 3. The easiest numbers, I'm going to use negative 1, 0, 1. These are my x values. These are my y values. We substitute. Now, this one, if I do it 3 times, I'm going to have to rearrange 3 times. I'm going to rearrange this one right now so it's y equals. What do I have to do first to have it y equals? Subtract 4. Subtract 4. Subtract 4. X minus 4 equals 2y. I'm going to solve for y. I need to divide everything by 2. Divide by 2, divide by 2, divide by 2. Y equals 1/2 x minus 2. X over 2 just means 1/2. If I put in, actually, I don't like negative 1, 0, and 1. Why not? I'm going to have fractions. I can pick any number I want, so I don't have to use negative 1, 0, and 1. What number would be better?
2.
What type of number, really? Even, because even numbers are divisible by 2. So I'll just pick negative 2, positive 2. It's easy to change a 1 into a 2. What's half of negative 2? Negative 1. What's a negative 1 and a negative 2? Negative 3. What's 0 times half? What 0 minus 2 is? Negative 2. Half of 2 is? 1 minus 2 is? Negative 1. Negative 2, negative 3, 0, negative 2, 2, negative 1. Again, if you look at the graph, it's a straight line. Why is this one not linear? X is being multiplied by y. Since it's x times y, it's not linear, and we are unable to graph right now. Y equals 5x minus 9. Is this one linear?
Yes.
Yes. I have a y. I have just an x. I can move things around if I wanted to. Graphing this. What numbers do you want to use? Bless you. Give me some numbers to use. 4, 6, 8. Would I want to use 4, 6, and 8? Why not? Nope. I can use all positive numbers. There's a reason why I probably don't want 4, 6, and 8.
Because they'll be really high.
They're going to be really large numbers and off our graph. We're going to have to change things. 1, 2, 3 work. We could use 1, 2, 3. I usually like to pick a positive and negatives, but 1, 2, 3 will work. What's 5 times 1? 5 minus 9. It's negative 4. 2 times 5 is 10. Minus 1. Or sorry, minus 9 is 1. 5 times 3 is 15. Minus 9, 6. 1, negative 4, and of course my calculator's in the way.
You did negative 1, negative 4.
Great thing about technology, I can fix it. 2, 1, and 3, 6. I could take and draw a line. It's linear. We're going to be doing a lot of graphing this chapter. Sometimes we have graphs that are not horizontal. The domain and ranges are real numbers. Sometimes we're restricted. We can't have negative numbers sometimes. And also, sometimes the domain or ranges are restricted even further. Sometimes you're only given a certain number of numbers you're allowed. I have an approximate relationship between human years and dog years. Is y equals 7x. So for every one of our years, it's technically a dog's 7 years. So if you've had a dog for 1 year, technically he's like a 7-year-old dog. We're going to graph this function and give its domain and range. Now for this one here, it doesn't make sense to have negative numbers because we can't have negative time. So we can only use positive numbers. So I'll use 1, 2, 3. Plug it into the graph. What's 1 times 7? 2 times 7. And 3 times 7. It's 21. Now, I have a little problem. I can't graph by ones. I have a problem with that. I am unable to go to 21, or vertically. What can I do? I could go by 2s, go by 3s, go by 4s. I do not have to always go by 1s. And that's where some of you make mistakes. You think you have to count all the way up. I'm going to count by 3s, just to be different. I can still count by 1s here. When I put this 3 here, it means all of these are counting by 3s. At 1, it's 7. How many lines do I need? I do not need 7 lines.
2.5.
Not 2.5. I need, let's see, 3, 6, and a little bit. 2 is 14. How many lines do I need? How many times does 3 go into 14? See, you got to think. 4 times. 3 times 4 is 12, and it's almost the next one. So I got 3, 6, 9, 12, and it's not quite 15. 21 is 7 exactly. 1, 2, 3, 4, 5, 6, 7. Even though I don't count by ones, the graph is still linear. All right, at a salon, Sue can rent a station for $10 a day plus $3 per manicure. And the amount that she would pay each day is given by f of x equals 3x plus 10, where x is the number of manicures. I have a couple issues here. What's the first issue? Nope. F of x just means it's a function of x. What's the first issue I might have? Anyone know? Yes. Nope, this is fine here. When I'm talking about the numbers for my table, I do have some limitations. Can't use negative. You can't give a negative amount of manicures. It's impossible to do that. There's also another stipulation. We didn't talk about it on this one, but there's a stipulation here. If I ask most of you how old you are, you're mostly going to say the same age, correct? All right. What's your age, roughly? 15, 14, 15. But you're not saying, are you exactly 14 years old? No, you're just saying 14, right? Could I have put 1.2 years in for someone's age? Yes. You're not exactly 14 years old. You're 14 point something. Could I put 14 point something in there? Yes. Can I put 2.5 manicures? Why not? You still pay for the job. So I can only put positive whole numbers here. So I'll just use 1, 2, 3. X, Y. Now substitute in. What's 3 times 1? 3 plus 10 is 13. 2 times 3 is 6. 6 plus 10 is 16. 3 times 3, 9 plus 10 is 19. Now, I can't fit this graph, so I'm going to count by twos. So 1 is 2, 4, 6, 8, 10, 12, 13. 16. And 19. And there's your graph. Now, the domain is 1, 2, 3, 4, 5, 6, 7, and goes on forever. The range is 13, 16, 19, 22, 25, and so on.